now do the demonstration for our web application, which is a hotel booking system. Here we can see the repo project for on GitHub for our web booking system, and here are the uh, instructions for running it on our computer. And here I already followed the instructions to run it using VS Code. Now I will show the website, which is here. This is the homepage, as it says, and here it shows the pricing of each hotel rooms. We have an about section for a hotel, a contact page, and now to book for rooms on a hotel, we need to register first. Now, if I just type password on the hotel, just type PASWRD, it will detect that it's too short. So now, I will type a secure password. Now, it's successful. Now, here we can go book a room for a hostel, and we can just pick 201 single room, check 19 till like 3 days monthly person and create booking. As you can see, we get to see the booking. This is on the modern bookings, and we can also edit according to what we want. We can also add more. Same 4 days, add two, and here it adds more to our hotel. And this is our dashboard, just same thing. And now we will log out from our account and go to the home admin page. And here we just need to type admin page on the link. The password is admin123 password. And here we can see the groups, the users. We see the audit logs. We can change group from users. And here we can see the status of each users. You see on the booking system audit logs, we can see the IP address, the time the users access the website, and each action they took. Here we can see the room bookings for each user, for each room, and the user profile we can change. And that's all from me. Thanks.
Next is the OWASP security control implemented. First is the input variation. The OWASP standard is V5A1. We use reject variation, file upload check with size and whitelist constraint. Email and username uniqueness check, range validation, date validations, and parameterize or RM queries in the Django. This injection free development prevent SQL injection, SSS, and other input-based attack by sanitizing and validating everything at the entry point. And next is the authentication and session management. For the OWASP standard is V2 and A2 leverage the Django authenticate function, CSRF token, HTTP only cookies, a 13 minutes timeout, same site equal to street attributes, and strong password validator requiring at least 12 characters. This feature ensures secure login, protect against session hijacking, and enforce best practice for user session. And next is access control. V4 or F5 include login required character, staff member requirement, either prevent role-based access control, and user scope queries. This granular control stop unauthorized access, like user viewing data that isn't there, through the Django middleware and decorator. Next is for error handling. Under OWASP standard V7, we implemented try catch block to manage exceptions gracefully. We use generic error message for user, custom page for 403, 404, and 500 responses, and ensure no start tracer are exposed to prevent information leakage. All errors are logged server side only, keeping sensitive data away from potential attackers. Next is sensitive data protection. Aligned with V3 and A6, we store environment variables in a Python file, keep the secret key in and control debug mode. Whitelist allow host and hash password using strong algorithm like PBK DF2, Argon2, and bcrypt. This multiple layer approach ensure that credential and another sensitive info are exposed in code or during runtime. Then file upload security. Under V5 and A5 included a 5 MB size limit, an extension whitelist for format like JPEG, PNG, and GIF, meme type validation, secure upload configuration, and isolation in a media root directory. This measure prevent malicious file upload that could lead to server compromise. Next is the configuration security under V3 and A6. Involve environment-based config managed via file production, debug disable, and security middleware enable for CSRF, X-frame, and authentication protections. This ensures our apps run securely in production without leaking dev mode info. And next is logging and monitoring. Under V7, features centralized secure logging, fail logging tracking with IP or timestamp, idle attempt warning, rotating file handler with a 10 MB max, and audit log module. This allows us to monitor and respond to suspicious activity in real time. And lastly, for the output and coding, under V5 and A3 include the Content Security Policy (CPS) header, XSS protection, enable X-frame options set to same origin, Django auto escaping, and built-in XSS protections. This prevent output related attack like cross-site scripting by encoding and restricting how content is rendered. And and next, for the security implementation summary, this slide gives a high-level overview for our achievement. We have implemented 9 major security control categories, achieving full alignment with OWASP ASVS v 4.0 by applying the Django framework best practice. We have focused on injection-free development using ORM-based queries. Our multi-layer defense strategy include comprehensive testing like manual review, static code analysis, static application security testing, dynamic application security testing, and penetration testing. The result, no critical exploitable vulnerability found, a testament to our proactive approach. To continue, and I will pass to next team member.
In this slide, I will cover the software component analysis result. We use SNCC to analyze third-party and open-source dependencies within the application. The primary goals were to identify all external components, detect known vulnerabilities using CVE, and assess any potential license compliance risks. The scan identified multiple known vulnerabilities across core dependencies. The most impacted components were the Django REST framework, and SQFRs, which are foundational to the application. Additionally, SNCC automatically generated a software bill of material (SBOM) by analyzing dependency configuration files, giving us full visibility into application supply chain. The slide summarizes the most significant vulnerabilities identified during SCA, categorized by severity. At a critical level, the Django JSON field was found vulnerable to arbitrary SQL execution, tracked as CVE 2023 to 4580. At a high severity, the Django was affected by a common injection vulnerability mapped to CWE 78 and CVE 2022 41323. Several medium severity issues were also identified, include cross-site scripting in the Django REST framework, denial of service vulnerability in SQL pass, and uh, those issues related to the Django float format filter. This finding indicate that even widely used framework can introduce significant risks if not properly updated. For this slide, additional SCA observation. Beyond direct vulnerabilities, we also identified additional risk factors. One key observation was potential path traversal risks in custom file storage classes that inherit from the Django storage class. If the generate file name method is overridden without proper validation, it could allow attacker to manipulate file path. From licensing perspective, the results were positive. All dependencies use permissive license, such as BSD and Apache 2.0, and no copyleft or compliance risks were detected. Moving on to static analysis, SNCC will also use to scan the application source code. The scan confirm several critical and high-risk issues, including SQL injection through the Django JSON file usage and command injection vulnerabilities. We also identify cross-site scripting issue, multiple denial or survey condition related to language handling, template files, and SQL equation. Additional finding included an authentication timing attack, email enumeration through the password reset form, and directory travel leaks in custom storage implementation. These results highlight both framework level and application specific weakness. Use OWASP to evaluate the running application. Several security misconfiguration were detected, including the absence of a content security policy, insecure cost configuration, and cookies missing the secure flag, where we also observed missing HTTP, straight transport security, server version disclosure through response headers, and weak or missing cache control headers. This issue increase the application's exposure to client-side attack and information leakage. Finally, this slide covers informational finding from WhatsApp. The tool successfully detected authentication requests, session management token, and identified the application as a modern Ajax-based web application. Zeb also flagged several XSS hotspots. While these are not confirmed vulnerabilities, they require manual review to determine exploitability. Through informational, these findings provide useful context and guide further manual testing.
So hi guys, for my part of the presentation, I will discussing on how we can prevent an injection attacks in our hotel booking system. So as you know, the injection attacks are part of the OWASP top 10, which mean they are one of the most critical security issues that we are facing today. So the injection occurs when a malicious input is sent to interpret like the MySQL or the database, OS command, or even the LDAP. So because of these risks are very serious, because the attackers can steal our data to gain unauthorized access or completely compromise our system. So this is why implementing a proper prevention techniques was very crucial for our hotel booking project. So how did we can prevent the attack? Of course, the most important techniques are the four key. Firstly, we are going to use the Django ORM with a parameterized queries which prevent a raw SQL injection entirely. Second, we could apply an input validation using a regex, range checks and uniqueness check to ensure all the data coming into our system are legitimate. So and the third one, we use output encoding the Django auto escaping features. This one is to block cross-site scripting attacks. And the last one, finally, we are going to implement a proper error handling with a generate message and custom error page, making sure that we don't leak any sensitive information like stack trace to the potential attackers. Okay, so of course the prevention isn't just about the code, it is about the also the configuration and the testing. So for the configuration security, we use environment-based secret keys with no hard-coded fallbacks. This one it implement a secure cookies with HTTP only and secure flags. This one could enable CSRF protection and enforce CSP headers to prevent an unsafe inline scripts. For verification, we conducted a manual code review where we flagged and fixed the high risk issue that we found, and we used OWASP ZEP for dynamic testing to confirm our implementation was truly injection free. So these two ways approach ensure that the both secure development and validation. So yep, in conclusion, these are our key takeaways. We know that injection prevention requires a layer of defense. There is no single technique is enough. Uh, because of this, the combination of secure coding, a proper configuration, and throughout testing creates a resilient against this kind of attacks. So in our hotel booking project, we successfully adopted the OWASP ASVS control. We achieve an injection-free coding practice and demonstrate a practical, discipline and approach to secure software development. So this framework can be applied to any web application to significantly improve their security posture. So that's all from us. Thank you.